Okay, for some reason I found 26 to be incredibly difficult. I'm not sure my analysis is correct, but it's what I came up with. So just to think about it, I want to point out what I did to think about it was there's two end guests and there's a host and hostess. So I thought of a symmetric table like this where the host and hostess were here. That means there's n minus one guest on this side and n minus guest on the other side. And so the first consideration was, I know the orderings of what's going on here. For example, the ordering of this thing, there's two different ways of doing that. And then there's going to be 2n minus 2 factorial orderings of that. But then you got to account for when they're sitting together, and you got to break that up. Furthermore, you got to consider that this thing here, host and hostess, could be rotated through the problem, right? What do you mean by rotating it up? Once you get the ordering is, you have to start considering that this could rotate around the room. The case where they are, where the guests are not supposed to sit together, are not sitting together, and the case where they are sitting together, where the host would have to break them up. And I come up with this analysis over here. But again, I'm not thoroughly convinced that this is true, all right? But that's my analysis. It took me time to get through it, and I'll be honest with you, it kind of busted my brain open a little bit, all right? That's one thing I want to tell you about counting. I always think, counting, people often think is a trivial activity. It is not a trivial activity. It's a difficult activity. And people can miscount. And you know what? Maybe I miscounted here. That's what I came up with. If you want, if you come up with perhaps a better set of reasoning skills than mine, please reach out to me, all right? My name is Ron Bannon. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. Thank you.